Hello, Vaishnavi. How are you?
Fine, ma'am.
So you are the only one who has done the last week's assignment. So any doubts or any difficulties you have?
Ma'am, I just need to practice more related to those.
Which one?
Ma'am, I just need to practice a little more on those, ma'am, because I couldn't do it on my own. Like every problem, I couldn't do it on my own. I just referred sites, but still, I'm working on it.
Okay. So these were all MCQs on the first part of the solutions chapter.
Yes, ma'am, and there were some numericals also, ma'am.
So since you know that the problem is that we haven't completed, no, so when they make the questions, some questions get mixed up. That is why. So you'll be able to. I'm sure you'll be able to do. Sanjay, how are you?
Fine,
See, when I'm talking to you, particularly at that point of time, you should switch on your camera. How are you, Sanjay?
fine.
So, are you revising? Are you able to understand any doubts?
Ma'am, I guess the voice is breaking. Not able
See, on my end,
to
there is no
guess
issue.
what is it. One minute.
On my end, just check your internet connection. Yeah, because if you keep the camera open, then you will not hear me well. So probably that's the reason. Madhavan, how are you? Kalpagesh, how are you?
Yes, ma'am. Fine.
So could you complete the recording of the previous things that you had missed?
Yes, ma'am.
Yeah. So did you try to do the assignments of alkyl halides and alkyl
Yes, ma'am. I just still have some 2 worksheets to complete. I'm just still
Okay.
to.
So as you finish, please update it.
Okay.
Okay.
Ma'am, do you have this display?
So I'm sharing my screen now. I'm starting because it's already 5 minutes. Some others may be a little late. So yes, tell me.
Ma'am, do you have this Saturday?
This Saturday, they haven't told me anything, but I had sent some notes on alkyl halides and aryl halide. Did you get that, all of you?
Yes, ma'am.
Yeah, so those notes, yeah, so go through those notes. That might help you for the test that is there on this Saturday. You have a test, right? Test coming up.
Not sure, ma'am.
Yes, ma'am, we have, ma'am.
Is it on this Saturday?
Yes.
Yeah, so revise. It's only alkyl halides and aryl halides for the test. Okay, so I'll go through what we did in the last 2 classes in solutions chapter. So we were first learning different ways to express the concentration. And then we learned how to calculate mole fractions and all that. And then after that, in the next class, we talked about molality, all those things we did. And then in the last class, we talked about solubility, right? So solubility of solids in liquids, then solubility of liquids in liquids, then we did Henry's law, right? And then we talked about some numericals of Henry's law, and then we came to vapor pressure. So I explained about vapor pressure, the relation between vapor pressure and boiling point. I hope you remember all that. Vapor pressure and boiling point, the temperature at which vapor pressure becomes equal to the atmospheric pressure, that is known as the boiling point. Then we talked about this boiling point, then factors which affect the vapor pressure, the temperature, the nature of the liquid, and intermolecular forces of attraction. Then we talked about vapor pressure of solutions. That is what we did last time. So we did this Raoult's law, and then we did some problems based on that. Then after that, we have now done two types of solutions, ideal and non-ideal solutions, and solutions of two volatile liquids, right? Azeotropic mixtures, all that. Now today we are going to start with colligative properties. Okay, I don't know why the rest of them are not there. This is a very important topic actually. From solutions now only we are beginning the actual important part of solutions, colligative properties. So the colligative properties, actually they are special type of properties of mostly we talk about dilute solutions. Okay, properties of dilute solutions. And these properties, they depend on the number of solute particles and not on the nature. So what are colligative properties? Properties which depend on the number of solute particles. Okay, and not on the nature of the particles. It only depends on the number of solute particles and not on the nature of solute particles. So what I mean to say is that if I have 1 molar solution of, or if I take water and I add 1 mole of urea, or I add 1 mole of sugar, or I add 1 mole of sucrose or glucose, it will have the same effect on these properties. Now, what are these colligative properties? Which are these colligative properties? We are going to talk of 4 colligative properties. First one of them is lowering of vapor pressure. Lowering of vapor pressure. The second property is elevation of boiling point. The third property is depression of freezing point. And the fourth property is osmotic pressure. Okay, so these are the 4 properties that we will learn in detail. Okay, 4 properties that we will learn in detail. Let me find out why these people are not coming. Okay, so we will take up the first one, and that is lowering of vapor pressure. So let us first try to understand. Now, supposing we have a beaker, a vessel, in which I have a pure solvent, only the solvent. Okay, so this is the pure solvent, right? And these are the solvent molecules here on the surface. And they are evaporating. Okay, I have already explained this. So some solvent molecules which are on the surface, they will evaporate. So there will be some evaporation. After some time, there will also be condensation. The point at which the rate of evaporation becomes equal to the point of condensation. At that point, the vapor pressure is the vapor pressure of the pure solvent. So let us assume that the vapor pressure vapor pressure of pure solvent is equal to P0. P naught is the vapor pressure of the pure solvent. Now what I do is, in the same container, I add a solute. And what type of solute now? The solute is non-volatile solute. Okay. So I add a non-volatile solute. So these are my solute particles. They will occupy some place on the surface. And because they are occupying some place on the surface, what will happen here? The number of particles of the solvent, they will reduce on the surface. All right? They will reduce on the surface. So what will happen? What will happen to the vapor pressure? Madhavan, what will happen to the vapor pressure now?
Increase.
See, these particles on the surface, they were evaporating, right? So what will happen to the vapor pressure of the pure solvent?
Decrease, ma'am.
It will decrease, right? So here
Yes, ma'am.
we have a solution. So vapor pressure of the solution, will decrease. So let us assume that the vapor pressure of the solution is PS. Okay, so PS. So change in vapor pressure will be what? Delta P will be equal to P0 minus PS. P naught minus PS. All right, because the vapor pressure will decrease. So vapor pressure will decrease. Right? So this has become what? Lowering of vapor pressure. Okay, so this delta P is what? Lowering of vapor pressure. Okay, lowering of vapor pressure is equal to vapor pressure of pure solvent, that is P0, minus the vapor pressure of the solution, that is PS. So the vapor pressure will slowly reduce, and lowering of vapor pressure will be equal to vapor pressure of the pure solvent minus the vapor pressure of the solution. Okay, so that is delta P. Now I have to come back to what we learned earlier. Okay, so what did we learn earlier? Now I will draw this, I'll copy it here back. Okay, so this is my solution now. Now, what we learned in Raoult's law, when we were doing Raoult's law, what did we learn? We learned that P total is equal to partial pressure of A plus partial pressure of B. You remember this? We learned P total is equal to PA plus PB. Here, what is P total? Instead of P total, we can say PS, that is the vapor pressure of the solution. So vapor pressure of the solution, S, is equal to PA, that is what is partial pressure of A, that is equal to the, according to the Raoult's law, what is that? It is a product of pressure P0A into XA. You remember this? Plus P0B into XB. P0B into XB. Do you remember this? Madhavan, are you able to recall? I can show you this from the previous slides. We had done it here, you see. We did this, isn't it? P total is equal to PA plus PB. And according to Raoult's law, partial pressure, vapor pressure of a liquid in a solution is proportional to its mole fraction in the solution. So here, how do we find out? P0A into XA plus P0B into XB. So I'm just doing the same thing. I have just written from there, I'm going to derive the new law. So instead of P total, what did I write? P total of the solution, that is equal to P0A plus. Now, let us assume that PB, P0B is what? It is the partial pressure of, it is the pressure of pure solute. That is, it is the vapor pressure of the solute. P0B is what? It is the vapor pressure of solute. And what type of solute it is? It is, I told you, it is a non-volatile solute. Right? And if it is a non-volatile solute, what will be its vapor pressure, Vaishnavi? If it is a non-volatile solute, will it have any vapor pressure? It will not evaporate. Solids don't evaporate. So its vapor pressure will be equal to 0.
0.
Right? So I can say PS is equal to P0A into XA plus 0. Because this whole thing will become 0. Why? Because P0B is 0. Because it is a non-volatile solute.
Ma'am,
Yes, tell me.
ma'am, for sublimation process, what will happen?
Sublimation process is a very rare case. It is a very rare case. And in the beginning itself, when I begin, I have made an assumption that my solute is a non-volatile solute. Okay. Volatile solutes like those which which you mentioned, sublimation process, there they also on dissolving in water are they becoming sublime. You can't hear? Are you able to hear, Vaishnavi? Are you able to hear?
Yes, ma'am. Yes, ma'am.
Hari Raghav, just try increase your volume. Now can you hear? Hello? Hari Raghav? Now Sai Kalyan, all are there now. Good, good, good. Yes, I think he will join again. So PS is equal to P0A. Hari Raghav, when you are back, you can ask me again, I will explain. So PS will become P0A plus into XA. Okay, can I write like this? PS is equal to P0A into XA. Now I will write here, you know, XA plus XB is equal to what? It is equal to 1. I told you the XA is a mole fraction of A plus XB is equal to the mole fraction of B, and sum of mole fractions of all components is also always equal to 1. Right? So from this equation, I can say XA is equal to 1 minus XB. Okay, mole fraction of B. B is my solute. Okay, BXB is the mole fraction of solute. So I can substitute this value here and I can write PS is equal to P0A minus, no, into, sorry. P0A into 1 minus XB. Or I can say PS is equal to P0A multiplied P0A minus P0A into XB. All right. Or I can say, I'll take it to the next page. This I'm carrying it to the next page. PS is equal to P0A minus P0A into XB. Okay, so I can say P0A minus PS is equal to P0A into XB, right? Or I can say P0A minus PS upon P0A is equal to XB. This is my what is P0A? P0A is the what you call vapor pressure of the pure solvent. So instead of now, since you know this is a vapor pressure of a pure solvent, you can just write it as P0, P0 minus PS upon P0 or P0 is equal to XB, mole fraction of B. So I can put it into words. Now what I got on the left side, this is PS. P0 minus PS, I told you what is it? It is lowering of vapor pressure. And in comparison to the vapor pressure of P0, what does it become? It becomes RLVP. What does RLVP stand for? Relative lowering of vapor pressure. Relative lowering of vapor pressure. And what is relative lowering of vapor pressure equal to? Relative lowering of vapor pressure is equal to the mole fraction of the solute. Mole fraction of the solute. Okay, so this is the law. Relative lowering of vapor pressure is equal to the mole fraction of the solute. Okay, so this is my formula. Relative lowering of vapor pressure is equal to the mole fraction of the solute. Okay, from now on, what I will do is so that it is like what is there written in your textbook. I will consider everything which is B is all relating to the solute, and everything which is A is relating to the solvent. We will do that always. Anything which is relating to the solute is B, and anything relating to the solvent is A. Subscript A refers to the solvent, subscript B refers to the solute. Okay. Now let us expand this formula a little. So P0 minus PS upon P0 is equal to XB. This is our formula. Now I will expand this XB. So P naught minus PS upon P naught is equal to NB upon N1, NA plus NB. You know that. What is mole fraction of component B? It is number of moles of B divided by total number of moles. Okay. Now, if the solution is very dilute, if the solution is very dilute, okay, mostly you will have dilute solutions. If the solution is very dilute, you know, like for example, if there is only 1 gram of urea dissolved in 1000 grams of water, you know it is a very dilute solution. Most times they will give you dilute. In that case, Na can be neglected, Nb can be neglected. Nb can be neglected in the denominator. Neglected in the denominator. So what will it become now? P0 minus PS upon P0, P naught is equal to NB upon NA. Then it becomes easy to do the questions. Okay. Now what is NB? NB is equal to the mass of A. So we can B, mass means WB upon MB. What is WB? Weight of B, mass of B divided by molar mass of B. And what is NA? NA is WA upon molar mass of A. Right? So this equation 1, how can I rewrite here? I can rewrite this equation here like P0 minus PS upon P0. P naught, people say P naught minus PS upon P0. P naught is equal to WB into MA divided by MB into WA. This is our equation which we will use in the following problems. Now in this case, what will happen? Either your mostly the mass of the molar mass of the solute you have to find out. Okay, we have to find out the molar mass of solute using this equation. Okay, so let us see a few questions how we are going to. Have you noted down the equation? And do you understand each component here? P0 is the vapor pressure of the pure solvent. PS is the vapor pressure of the solution. Then WB is the mass of the solute. MB, molar mass of the solute. MA is the mass of the solvent. And WA is the, MA is the molar mass of the solvent. WA is the mass of the solvent. So we can find out any one quantity which is unknown. Okay. So what did I do? I substituted these values here in NB by NA and I got this formula. Okay. So now let us do a few questions. The vapor pressure of pure benzene. Can you all see it or shall I? What is it?
Again, go to first screen. You know, like for a second, go to the before screen.
You want to
slide.
Last slide. Okay.
Yes, ma'am. Thank you.
Now this is the question. I'll increase the font. Okay. So vapor pressure of pure benzene at a certain temperature is 0.850 bar. What is the measure? What is the bar is a unit of which quantity? It is a unit of Madhavan. Bar is a unit of which thing? What do we measure in bars? Sanjay, what do we measure in bars?
Vapor pressure.
Vapor pressure, right? So vapor pressure of pure so atmosphere, bar, millimeters of mercury, pascals, kilopascals, you can measure the pressure in various quantities, but here it is in bars, right? Now, non-volatile, non-electrolyte solid weighing 0.5 grams when added to 39 grams of benzene, molar mass 78. Then vapor pressure of the solution then is 0.845. What is the molar mass of the solid substance? Okay, so first find out, write down what is the data that is given to you. Always write down the data in these questions. There will be 2 such numericals in your paper. You should be able to do this in your exam. You should be able to do it thoroughly. They are very, very easy. Once you understand, there is no problem. So first write down the data that is given to you. So vapor pressure of pure benzene. So what is pure benzene? Vapor pressure of pure solvent, P naught is equal to what? 0.850 atmospheres, right? Then what is the next thing given? Solute, mass of the solute. So WB is equal to 0.5 grams. Mass of benzene is the solvent. So WA is equal to 39 grams. Then molar mass of benzene, so that is MA is equal to 78 grams. Vapor pressure of the solution, that is PS, is equal to 0.845 atmospheres. Right? And what is it that you have to find out? MV. Can you do that? It is straightforward. What is the formula? P0 minus PS upon P0 is equal to WA. No, it is equal to WB into MA divided by MB into WA. Now substitute. So there is 1 mark for writing the formula. This question can carry 3 marks. So 1 mark is for just writing the correct formula. So write it properly. Then you write on substituting all the values, right? So substitute P0 0.850 minus PS 0.845 divided by 0.850 is equal to WB is 0.5 into MA is 78 divided by MB we have to find out into WA 39. So on simplifying, this is on the top, what will you get? 0.005, isn't it? Here you see 850 minus 0.845. So what will you get? So it is 0. What is it, Vaishnavi?
170.
What did you get answer?
170.
17. 170. 170. Let's just check the answer. Yes, answer is 170. So 0.005 divided by 0.850 is equal to 0.5. This also get cancelled, 2 into 2 divided by MB. So if you do the calculation, you will get MB is equal to 170 gram per mole. Okay, answer is, the unit should be correct. It is gram per mole. All of you understood how to do this?
Yes, ma'am.
Oh, a new person has come today. Sai Kalyan, I didn't hear you at all. How are you doing?
I'm fine, ma'am.
So got 170?
Yes, ma'am.
Hariharan, how about you?
Fine, ma'am.
Ashwin, just switch on your camera. I want to see you. I don't think, were you there in your last class, Ashwin? In the last class? I think, I can't recall. Ashwin Shiva, are you there? Hello? Hari Raghav, did you understand? Hari Raghav, did you understand?
Ma'am, yes, ma'am.
Okay,
Yes, ma'am.
okay. Sanjay, what about you?
Yes, ma'am.
Okay, now our next question I will give you, and all of you should try to do it without my help. I am increasing the font 24. Okay. Now let me see who will give me the answer first. Do it. Now this time the only change is that your pressure is given in kilopascals. So just do it. Only two children are obedient here. One is Madhavan and the other is Sanjay. They are switching on, they have switched on the camera. In case of Hari Raghav, I know if you switch on the camera, you can't hear me. So if you, unless your bandwidth is giving you a problem, please switch on your camera.
Yes, ma'am.
Yeah, somebody who said yes, your bandwidth is also not good. Ashwin, are you there? Ashwin Shiva, are you there? Ashwin. So you have joined and you have disappeared. Kalpagesh, are you able to understand what to do?
Yes. Right.
Hmm. I'm deleting this part. You just do the first part first. You all might find it a little difficult to do this question. I think I need to change it. Children, do that question as a homework. Please note it down. Right now, do this question first. Till you become more confident, please leave that question, do this one first, because there we are changing, we are changing the concentration and then changing the vapor pressure. We will take it up after this one. Just do this first. Once you do 2, 3 of this type, then we will take it up. Do this one. Oh my, sorry. I'm so sorry. This is also another type. You can't do this because can you make out what is the problem? Who will tell me what is the problem in this question? Anyone? This has to be done not by this method. Can anyone tell me what is the problem in this question?
And the molar mass.
See, no. See the question. This question has another problem. This also I will send. Please note it down and do it as a homework. This is a question where I should give you those questions where one of the solute is non-volatile. Then only you can talk about relative lowering of vapor pressure. Here both are liquids. So this has to be done by Raoult's law that we did on the first day. Both are liquid. So you will have to find the mole fraction of each one of them. You will have to find the partial pressure of each one of them. And the sum of partial pressures will give you the total pressure of the solution. Okay. So this is difficult. You can't, right now it is not what I want you to do. Let us try. Do this one. I have all the choices also. Do this one. I'm sorry, both the questions I didn't see them. I just copied and kept there, but I didn't check them. Vapor pressure of water in solution having 40 grams, 50 grams of urea dissolved in 85 grams of water. Vapor pressure of pure water is 298. At 298 is 23. And for urea, I can give you the molar mass. The molar mass of urea. Urea is equal to 60. And molar mass of water, molar mass of H2O is equal to 18. Now do it. Anyone found the answer? Sai Kalyan, are you doing it? Hello?
Yes, ma'am, I'm doing it.
Yeah, please do it. You should be able to do this question in 1 minute. Vaishnavi, did you get the answer? You're generally first to get the. Yeah, do it. Sanjay, did you understand how I put the values in this formula?
Yes, ma'am. 1 minute. That's it.
Yeah.
Ma'am, is it 23.33?
Yeah, approximately it should be the first one. The answer is first one.
Okay.
All of you got it? If you have not got, if you have substituted your values correctly, then let me go to the next question. Hariharan, Ashwin, are you there?
There.
Hari Raghav, did you get?
The answer is first one, ma'am.
Kalpagesh, did you get the answer?
Yes, ma'am.
Okay. Ashwin, I have not heard from you. Ashwin Shiva. Hello. Okay, now do this question. Next one. Now, what is the trick in the next question? The question is the vapor pressure of 1 molar solution of a non-volatile solute in water is 300 water at 300 K would be. The vapor pressure of water is given there. Okay. So how would you do this question? Now, in this question, what is the trick of doing this question? They have not given you the mass of the solute, right? But they have given you 1 molar solution. 1 molar solution means what? 1 molar solution means 1 mole per kilogram. Per by 1 kilogram of solvent. Right? So you know the number of moles of the solute and you know the mass of the solvent. So can we do this question? So this is P0 minus PS upon P0, right? We'll have to do it by our other formula where we are not finding, we have to find the vapor pressure of the non-volatile of the solution, right? So we will use the other formula which says NB upon NA plus NB. All right. So what will we do? P0 is 12.3 minus PS upon 12.3 is equal to NB is 1, right? And Na is how much? Mass of the solvent is 1 kilogram. So 1 kilogram is equal to Na will be equal to 1000 divided by 18, number of moles of water. So mass of water is 1000, molar mass is 18. So 1000 by 18, that will come to 55.55. So 55.55 plus 1. Right, now do it. Find the correct answer. So it will be 12.3 minus PS is equal to 12.3 divided by 56.55. So you can find the value of PS. Quickly do it. Right now, since we are only practicing, you can use the calculator.
12.09.
Yeah, 12.09. So this answer is 2. You can all use a calculator till we are, becoming more, practicing more. So what was the difference here? We did not have the mass of the solute. So they had only given the number of moles of the solute. So that is why we did it by this method. Now all of you note down the method of doing and then you should do it by yourself. Note the question and you can do it by yourself. You can sometimes, if you want, if you are taking time, you can take a screenshot. Anyway, you get the recording, so there is no problem. Now let us go to the next question. Now this one, you have to find the molecular mass.
Ma'am, can you go to the previous? I'll just take a
Yeah.
screenshot.
Okay.
Okay.
Okay, now do this question. All of you need not do the calculations, children. You can do the calculations a little later, but quickly try to write the correct formula and substitute it in the formula. So the formula for relative lowering is the same. By this time, you should know by heart. P0 minus PS upon P0 is equal to NB upon NA plus NB. Now, if the question is to find out the molecular mass, then it is better to write the simpler one. You can write it as WV into MA divided by MB into WA. So we'll substitute in this one. So how will you do this? This is very easy. Hari Raghav, Vaishnavi. Hariharan, are you able to do?
Doing, ma'am.
Yes. Now, what is special in this case? Who will tell me? Sai Kalyan, you have not talked today. What is it that is given to you here? The whole value of this is given already in the data. We know what is the relative lowering. So what is the relative lowering? It is 7.13 into 10 raised to minus 3. Right? So it becomes much easier. This side is already given. What do we have to find? MB. So right here, all the values, WB is equal to what? 71.3 into MA is the molar mass of this water, that is 18, divided by MB that we have to find out into WA is 1000.
Ma'am, the value of MB will be 1.8.
Very good. 1.8. All of you got it? Yes or no? Let me see who didn't get it. Sai Kalyan got, Hariharan, Vaishnavi also got.
I got it.
Madhavan, did you get it?
No, ma'am.
Do the
No, I didn't.
calculation. Do the calculation.
No, ma'am. The problem is I couldn't still understand the question. So that's
Okay,
why.
okay. Let me explain to you. See, what is the question? Relative lowering of vapor caused by dissolving 71.3 grams of substance in 1000 grams of water is this much. You have to find the molecular mass of the substance. Okay. So as I told you, what is the first thing that you have to do? You have to first find out the, write down the data that you have. Okay. So the data is, first you have RLVP. What is RLVP? Relative lowering of vapor pressure. So what is that? It is 7.13 into 10 raised to minus 3. What is WB? WB is 7.13 grams. Here 71 point, not 7 point, 71.1. 71.3 grams, right? Then what is MB? You have to find out. I don't know. Then what is WA? Mass of the solvent. It is given here, 1000 grams. And what is MA? Molar mass of the solvent, that is 18 gram per mole, right? Now I put all these values here. So P0 minus PS upon P0 is what? It is RLVP, relative lowering. So this, instead of this whole thing, I can write 7.13 into 10 raised to minus 3. Instead of WB, I wrote here. Instead of MA, I wrote here. MB, I have to find, and this is WA, right? So what will be MB equal to? MB will be equal to 71.3 into 18 divided by 7.13 into 10 raised to minus 3 into 1000. Now did you understand?
Yes, ma'am. Understood.
So now the answer comes to 1.8. No, is Vaishnavi, please check the answer.
Ma'am,
Please check the answer.
ma'am, 71.3 and 7.13 get cancelled 10 times, ma'am. So 18 by 10.
18 by 10. This is 10. So what will it be?
Oh, 180.
180. Yes, it is 180 gram per mole. Okay, so answer is 1. Sai Kalyan, did you get it? You didn't point out the mistake which Vaishnavi made. Vaishnavi, did you understand your mistake? You reached correctly till the last step, but you made a calculation error.
Yes, ma'am.
Yeah. Shall I go to the next question? Hari Raghav, Hari Haran, at least say yes, ma'am. Please go to the next question. I can't hear you. I can't see you. What are you doing? Sai Kalyan, done?
Yes, ma'am, I was done.
Hari Raghav, done?
Yes, ma'am.
Hari Haran, done? Hello? Ashwin, have you done it? I'm going to make a note of all this. Ashwin? Okay, this is the next question. The vapor pressure of a pure liquid solvent is 0.8. When a non-volatile solute is substance B is added to the solvent, its vapor pressure drops to 0.60 atmosphere. What is the mole fraction of the component? B. What is the mole fraction of the component B? How will you do this? This is, you don't even have to write it. It is very easy. Let us try. What is the formula here? P0 minus PS upon P0 is equal to NB upon NA plus NB. We have to find what? We have to find this one, mole fraction of the solute. Okay, mole fraction of the component B. Now we have all these values. What is P0? P0 is given as 0.80 atmospheres. What is PS? It drops to 0.6, so it is 0.60 atmospheres, right? So how will I write 0.80 minus 0.60 upon 0.80? First find out this. So this is equal to what? 0.20. Hmm?
0.25.
Isn't it? It's 1/4. What is 1/4 equal to? 0.25. So relative lowering of vapor pressure. You found what?
Ma'am,
Yes.
ma'am, that right hand side, the 0.20, 0.8. Sorry, 1/4, ma'am. How it came?
0.2. See, look here. I will add one step in between, you will understand. Here, so this will become equal to 20 divided by 80, isn't it? So 20,
Ma'am, I'm asking about that n of b by n of a plus n of b.
so what is this? This is called what? This is called mole
That,
fraction. Mole fraction of B, isn't it?
Hmm.
What do we have to find out? Mole fraction of component B. That is the question. We have to find out this whole.
Okay, ma'am. Okay, ma'am.
So
Okay.
mole fraction of B is equal to what? RLVP. Relative
ma'am.
lowering of vapor pressure is equal to the mole fraction. Now, these two questions which I did, the last one, what was given? This whole thing was given. Relative lowering was given to you, and you had to calculate from here. This time, you have to calculate this whole thing. You have to find out mole fraction of B. You don't have to find the molar mass of the solvent or anything. Mole fraction. So relative lowering of vapor pressure is equal to what? It is equal to mole fraction. So once you find the relative lowering, that is 0.25, that is equal to what? RLVP is equal to what? It is equal to the mole fraction. Did all of you understand? Again, I'll ask you one by one. Vaishnavi, did you understand?
Yes, ma'am.
Okay, so this is only for you to thoroughly understand the concept. Hariharan, Hari Raghav, did you understand?
Yes, ma'am.
And Sai Kalyan, did you understand?
Yes, ma'am.
Sanjay, did you understand? Where is Sanjay? Is he there? He's not there. Okay. So now let us do the next question. No, this is on Raoult's law, so we'll leave this. Okay, who will tell me this one? These are all MCQs, so that's why I'm spending a little time on this. Tell me, how will you do this? Just think, equal weight of a solute is dissolved in equal weight of two solvents A and B to form dilute solutions. Relative lowering of vapor pressure for solution B is twice the relative lowering of vapor pressure of solution A. If MA and MB are molecular weights of solvents A and B respectively. Okay, so how will we do this? First, let us take, how will we do this question? First, let us take two solutions are there, no? So first let us take solution A. Okay, first solution. Now in solution A, what is it? Let the lowering of vapor pressure be X. Relative lowering of vapor pressure of B has twice the vapor pressure of, so this is X. X is equal to, we have to write equal weight of solutes, so is equal to WB into MA divided by MB into WB. No, WA, sorry. MB into WA. And for solution B, what do we have? For solution B, vapor pressure of solution B is twice the vapor pressure of solution A. So let us make it 2x is equal to, now the weight of solute is same, so weight of solute is WB into okay, MA and MB. Equal weight of solute is dissolved in solvents. I have repeated the same thing, but I have made the vapor pressure double here. Now, what are the things which are same? WB, the weight of the solute, this part is the same. WB and MB is the same. Okay. Now, instead of MB, I should write something else because here they are saying MB is this one. So let me make it WB, MB. How do I explain to you easily? So this weight and this molar mass is same, this is different. The equal weight of two solvents. So everything is same. Here you see mass of, so I will divide these two equations. This is equation 1 and this is equation 2.
Ma'am,
Yeah.
now one doubt, ma'am.
Huh.
Ma'am, will the weight of both will be same, ma'am?
Yeah, weight of everything. See, so this and this is same. Molar mass and molar mass is same. This WA and WA is also same. What is different is this one, MA and M. Here it is MB. This one, that is why I was trying to change it here. Let me make this M.
Ma'am, then if the answer is fourth line, ma'am, MA is equal to 2MB.
Yeah. So answer is, so let us do it. So so here it has become, so if I divide equation 2 by 1 on dividing 2 divided by 1, right? So if I divide equation 2 by 1, what will I get? 2x by x is equal to MB 2x is equal to MB by MA, right? So 2MA, x and x will also get cancelled. So 2MA is equal to MB. Right? Answer is 2. The second one. Vaishnavi?
Ma'am, but they have given like a relative lowering of vapor pressure of B has twice that of A. So it will be like RLVP of B is equal to 2 of RLVP A.
That is what, see here, relative lowering of vapor pressure of B is twice the vapor pressure of A. Relative lowering RLVP of B is twice the RLVP of A, isn't it?
Yes, ma'am.
So if RLVP of A is 2x, then RLVP of B is 2x, isn't it?
Yes,
Vaishnavi, what is your doubt?
Ma'am, I guess I went on. I'll just check it.
Hmm.
Ma'am, I did it like XA will be is equal XA will be equal to WB into MA by WA into MB, and
Hmm.
XB will be equal to WB into M dash A by W dash A into MB.
Hmm.
So XB will be twice of XA.
XB will be twice of XA. Hmm.
So
So
I just substituted and cancelled, and I got like MA is equal to 2.
MA is equal to 2B, 2MB.
Yes, ma'am.
Can you send a screen? Oh, you can't send it to me. Dividing 2 by 1. So 2x, this is MB, 2 is equal to x.
Ma'am, I have a doubt, ma'am, but how on the right hand side we get MB by MA, ma'am? Ma'am, if we do division, then everything will cancel now.
No, see here, that is why I was taking a little time to write down. I was wondering how to make it simple. See, instead of normally, this is my formula. Let me do it once again for the benefit of everyone. Okay, let us make it. Now let's see who is right. I could also be making an error here. Okay. Now in case of solution A,
I got.
in case of solution A, this is for everyone now. In case of solution A, let RLVP be X, right? Then let WB, that is molar mass of solvent, be B, right? And let molar mass of the solvent be M1. And let WA, molar mass of solute, be WA itself, or it can be A. And let MB, molar mass of A, be MA. Okay, now solution B, right? Vaishnavi, did you understand?
Yes, ma'am. Actually, I did it correct, ma'am. But in the final step, I
You are making a mistake in the final step. This will be 2x, right? Then let WB be equal to is also B here. And WMB is equal to M1 because the solute is the same, right? Let WA be equal to A. Weight is the same. And MA, let MA be equal to MB. The molar mass of the solvent be MB. Now what will be RLVP here? X into B into A and into MA divided by M1 into A, right? And the other one is 2x is equal to B into MB upon M1 into A, right? So this is equation 1 and this is equation 2. Now you divide 1 by 2. On dividing 1 by 2, or rather 2 by 1. It is better because in that case 2 will come on the top. So I'm dividing 2 by 1, right? So I will write 2x by x, right? And this whole thing by this whole thing. So everything will get cancelled here. B will get cancelled, M1 will get cancelled, A will get cancelled. What will remain? MA. So I will write here MA by MB. No, this is X. So MB by MA. Right? Okay. X and X will also get cancelled. So what will I get? 2MA is equal to MB. Now, if you have understood what I have been teaching for last 1 hour, all of you should in 1 minute give me the answer of this question. Don't say the answer. I will ask you one by one, all of you should give me. No calculation is required here. Vaishnavi, you are the first one. Question goes to you.
Ma'am,
What
0.25 atmosphere.
Just, what is it?
0.25 atmosphere.
Okay. So according to Vaishnavi, it is, answer is C. Right. Sai Kalyan, what is the answer?
Ma'am, it is C only, ma'am, because the molar fraction is equal to the RLVP.
Very good. Madhavan,
After cycle and give the explanation, I got the answer. Ma'am.
you got the
Before
answer.
that,
You
I
were
didn't
wondering.
understand.
Okay.
Yes.
Hariharan,
Ma'am,
what will be the answer?
for me, I think it's C.
I can't hear you. Say loudly.
Ma'am, I think it's C, ma'am.
It's C. You don't have to think, you have to be sure. So RLVP, relative lowering of vapor pressure, is equal to what? Mole fraction of the solute, right? So if RLVP is 0.025, what will be the mole fraction? 0.25. Hari Raghav, did you understand?
Ma'am, yes, ma'am.
Yeah. Okay. Now, so in this topic, now I will summarize what I taught till now. So in this topic, what are the important things that you learned? The most important thing that you learned was that P0 there is a, when I add a solute, there is a lowering of a vapor pressure, and relative lowering of vapor pressure is equal to the mole fraction of the solute. Okay, so mainly all my numericals I solved with this one only. All right. So either you have to find the vapor pressure of the pure solvent, or you have to find the vapor pressure of the solution, or you have to find the molar mass of the solute, right? So whatever you do, you follow this. Sometimes if the calculation is difficult, especially when you are doing the MCQs, you should always remember you can neglect the number of moles of solute in the denominator. And in that case, you can use WB into MA upon MB into WA. Okay, so using this also you can do. You should always remember these two terms, RLVP, relative lowering of vapor pressure, is equal to mole fraction of what? Mole fraction of the solute. Okay. So this was type 1, the first type of numericals which we have to do in this question. I showed you as many variations as were possible. I have shown you. Okay. Now we will do the next colligative property. There are 2 minutes, but I want to introduce that to you. And that is elevation of boiling point. Elevation of boiling point. Okay. So in the beginning itself, I showed you that if on adding a solute, the vapor pressure is lowered, then what will happen? The boiling point will increase. So if I show you the graph, which I have shown you earlier also. So here I show the pressure, vapor pressure, and here is my temperature, right? So if this is the vapor pressure of the pure solvent, so what happens? I increase the temperature, the vapor pressure of the pure solvent increases. And it reaches, after some time, it reaches this pressure, which is the atmospheric pressure. Okay, atmospheric pressure. When the vapor pressure of the pure solvent reaches the atmospheric pressure, that temperature is known as what? It is known as the boiling point of the pure, boiling point of the pure solvent. This was the solvent. Now I added a solute. By adding the solute, this is the vapor pressure P0, right? Now I added a solute. When I add a solute, what happens to the vapor pressure? It goes down. This is PS, vapor pressure of the solution. So now vapor pressure, if I increase the vapor pressure of the solution, what will happen? It will also increase with temperature. And now it will reach the atmospheric pressure. So if I drop it back and find the temperature here, this is T1 and this is T2, right? What will happen to the boiling point? What happened to the boiling point? The boiling point increases. Can you see? First the boiling point was T1, now it has become T2. So the boiling point increases on increasing the temperature. On adding the solute, the boiling point increases. So that increase in boiling point is known as elevation of boiling point, right? Now, what will this elevation of boiling point depend? It will depend on how much solute, the concentration of the solute, how much solute you have added. So here the formula is very easy. They say that increase in boiling point, that is elevation of boiling point, we call it delta TB. Final boiling point minus initial boiling point, that is delta TB, is proportional to the molality. Molality means the molality of the whatever solute, the concentration of the solute, which is expressed in molality. Why do we take molality? Because molality is not dependent on temperature. Otherwise, when you increase the temperature, the molarity will also change. So we take molality. Okay. Hari Raghav, do you know what molality? What is molality? M. It is equal to moles of solute.
It's
Divided by what?
given mass by molar mass divided by
Mass of?
kilograms.
Yeah, mass of.
Volume in kilogram.
Not volume, mass of solvent in kilogram.
Yes.
Mass of solvent in kilogram. And to remove this proportionality sign, we put a constant. TB is equal to KB into M. Okay, so next set of questions we are going to base on this. Relative lowering, elevation in boiling point is equal to the molality of the solution. Okay, is proportional to
What is KB, ma'am?
KB is the constant, which is known as ebullioscopic constant. Ebullioscopic constant. So this I will explain in more detail next week. But this week, I want you to go through each of these problems. We did 10 problems and I took a lot of time in explaining, and I did not do elevation in boiling point today because I wanted you to be thorough with what we did. So all these questions which I showed you, please solve them once again. And any question which you didn't understand, please come back and in the next class ask me. We will discuss it once again and then only we will move forward. Okay, so I want all of you to be thorough with this. Okay, so see you in the next class.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you.
You're welcome, all of you.
Ma'am,
Yes,
ma'am, for the upcoming test, is it like how should we prepare, ma'am?
see, one thing is you should go through all the notes. Okay,
Yes, ma'am.
then you go through all the assignments. You should be able to look at the questions which are given behind the textbook.
Yes, ma'am.
Okay, try to solve all those questions. It's an easy paper, it's not difficult. This is the first test. I think you should be able to do it. Do SN1, SN2, all those things properly.
Yes, ma'am.
Okay then, bye.
Ma'am, bye, ma'am.
If you have any doubts, please post them through Mr. Bhaskar. Tell them I
Yes.
will reply. Okay.
Okay, ma'am. Thank you.